Okay, so this is going to be a mixture problem, mixing acid in a chemistry class. If you've ever taken a chemistry class, you would have done something like this in any basic chemistry class. All right, so we're mixing acid to dilute the solution. That's what we're doing, we're diluting. So suppose our original amount of water mixed with acid, so we have pure water that was added to 200 milligrams. So that's our original amount. We have 200 milligrams of a solution that was 30% hydrochloric acid. All right, so it's 30% acid. We're going to add water to that 200 milliliters to dilute it to 15% of the mixture is acid. All right, so the original amount, 30% of it's acid. We're going to add water to it to make it 15% acidic. Alright, so we'll get to the nitty-gritty of that in a little bit. My first thing is, again, read through the problem and kind of put down what you know, what you don't know. And so what we're looking to find is we want to figure out how much more water do we need to add, right? That's the question. How much of that pure water should we add to our original solution, right? This was the original solution, to dilute it to the new solution mix. Okay, so we're going to add to the 200 milliliters. We're going to add water to it. All right, so and we want to know, well, how much exactly do we need to add to cut the acidity from 30% to 15%? So X is what we're looking for. X is the amount of water I'm going to add. So that's what I'm going to let X be. X is going to be the amount of pure water I'm going to add to the original 200 milliliter solution of 30% acid to make it diluted so that it's half as acidic. So it's only 15% acidic. So X represents the amount of pure water added. We started with 200 milligrams, so that means, well, when it's all said and done, the final volume would be what we started with, the 200, plus the amount we added. And that will be the 20% solution that I'm looking for. Right? And X is the unknown. All right, so again, we started with 200. We're going to add X to it. 200 was 30% acidic. We're adding X to it to get it to be 15% acidic. So that's what the second part is. So those are my variable parts. The setup, how we set up the equation. So just to kind of understand what's going on is we're adding pure water. That's all we're doing. We're adding X, pure water. So that's what we want to figure out is how much pure water do we need to add to the solution. What you have to know is the acid's not changing. Right? I'm not changing how much hydrochloric acid I have in it. Right? So the amount of acid I had before I added the water is the same as the amount of acid I have after I add the water. I just have more water in the second solution, right? Which makes it more diluted. More of the percent's water, less of the percent's acid, right? In the original one, we had 30% acid, 70% water. Well, we're going to add more water to make it 15% acid and 85% water. The milliliters of acid is not changing. It's the milliliters of water I'm adding to it. And so the amount of acid is staying the same. And so that's what we're going to use. That's the equality. I have the same amount, if I were looking at it in terms of milliliters, I have the same amount of milliliters of acid in the original solution as I do in the new solution. I just have more water in the new solution. And that's what I want to figure out, with how much more water. And so that's where the equality is going to come from. It's going to come from the fact that the amount of acid before the water is added equals the amount of acid after the water was added. So we have the same amount of pure acid, just different amounts of water. And actually that's what I want to figure out is how X is my different amount. How much is X? And so what we're going to do is we're going to take the amount of pure acid before we added the water, which is 30% of 200, set it equal to the amount of pure acid that we have after we've added to it. Well, the amount of pure acid would be 15% of the new volume level. All right, the X plus 200. All right, they're equal because they have the same amount of pure acid, but the percent's different because I have more water in the second than I do in the original. All right, so the equation is, well, the amount of acid in the original, so amount of acid in the original would be 300%, so here's where we're using a percent, it's 300% of 200. And so I take my 300%, change it to a decimal, so 0.3 times 200. That's how much acid is in the original amount. 30% of that 200 is acid. The rest of it's water. That equals 15% of the new amount. Alright, so that equals the amount of acid, because I didn't add any more acid, in the new solution, which is 15% of however much new water I have in my 200. So I started with 200. I added water to make it 15% acidic. I didn't add any acid, so I still have the same amount of acid. And so but now it's 15% of my new amount. So I changed my 15% to 0.15 and multiply it by the new amount of water and acid. So I add x plus 200. That's how much more water I have. And those are the same. I had the same amount of acid in both solution. I just have more water in the second one than I do in the first one. Right, there's more liters of water in that one. That's what I want to figure out what x is, that more liters of water. And so that's what I solved. Right? So there's the hard part. Once I've set it up, now I solve using my order of operations. So the first thing we're going to do is I'm going to multiply this side out. All right, and then distribute here. All right, so the first thing is I'm going to take my 30% times my 200, which means there's 30 times 200 is, there were 60 of the total amount of solution here. 60 milliliters was acid, which means 140 was water. In the second solution, there's still 60 milliliters of acid. All right, but I need to figure out, well, how much more water there was. Well, that would be the x, so I have to figure out how much more. And so I'm going to multiply through here, so I take my 0.15 times x plus my 0.15 times 200, which is 30. I solve for x, so subtract 30 from both sides. So over here, I'm going to get 30 equals 0.15x, and then the last step is to get rid of that 0.15 by dividing by it. And so 30 divided by 0.15 comes out to, so I actually have to double it. And that should make sense that I'm going to have to double it, right? Because I cut the amount of acid in half, right? It went from 30% to 15%. And so it should make sense that I actually have to double the amount of acid. So I have to add, or double, well, it's not quite double the amount of water, it's slightly more than double, right? Because I had 140 milligrams, so I have to double the amount of total liquid by adding 200 milligrams of water. So I'm going to add, so now my solution, add 200 milligrams, milliliters. All right, add 200 milliliters of pure water to the original solution. All right, there's my answer. That's how much more we're going to add. All right, so to check it. All right, so remember the original amount had 30% of my original was acid. So 30% of 200 was acid, so that was 60 milliliters of acid. I should still have 60 milliliters of acid when I add the new amount. So my new amount would be 200 plus the 200. Well, that's 400 milliliters is my new amount. And so that 400, if I take 15% of 400, it should come out to the same amount of acid. So I take my 0.15, multiply it by my 400, and it also comes out to 60 milliliters of acid, right? I have the same amount of acid, I just have a lot more water in the second one. The first one had 40 milligrams of, right, 140 milliliters of water. This one has 240 milliliters of water, all right, which why it's diluted in that case. And so there's a mixture example. And the book also has a video on, they do a similar method but slightly different than mine, so if you want to look at their video you can, just for one more place to go and have a little bit better understanding. Alright, so I'm going to have two more applications I'm going to go over. Actually, I might combine them in the same video on the next one. I have a working together example and an application of similar triangles, a geometry example. Alright, so we'll stop that one here.